Well, I'd like to look at some inequality problems today. And the first one I want to look at is the first one on Thursday's assignment. The problem says this. It says Kara has $25 to buy dry pet food and treats for the animal shelter. A pound of dog food costs $2 and the treats are $1 a piece. If she buys 9 pounds of food, what is the greatest number of treats that she can buy? All right, so let's start out first by writing some things down. This is what I want on your paper. So everybody should write down, first of all, that Kara, she's got $25. So what we want to know is how much can we buy so that she spends the money she has. Now the question is this. Can she spend $25? Yes or no?
No.
Well, she's got $25. So could she spend all 25?
Yes.
Sure, she could if she wanted to. She could spend 23. She could spend 20. She could spend 15. She could spend 1. But can she spend $26? No, why not? Because she doesn't have it, exactly. So here's what I want you to write down. She is going to spend less than or equal to $25. Write that down, please. She's going to spend less than or equal to 25. She can spend 25. She can spend less than 25. Let's get some more information from this problem that we're looking at. All right, so a pound of dog food costs $2. All right, so that's some information we would probably need. 1 pound of dog food, so dog food is $2 per pound. LB is abbreviation for pound, so I'm going to write it down that way. And the treats are $1 a piece. Okay, now we know that she buys 9 pounds of dog food. So my instructions say to write an inequality for this situation. All right? So the first thing I want to talk about is if she buys 9 pounds of dog food, then that's $9 per pound at $2 per pound, or 9 times 2. Before I can even write an inequality, I have to define a variable. Let's just say that X is the number of treats she buys. Don't know how many she's going to buy, but and so if X is the number of treats, each treat costs $1. So that's 1X, $1 times each treat. So I think we've got the pieces, the parts to assemble to write a pretty good inequality here. First of all, we know that she's going to buy 9 pounds. We said that was 9 times 2. And we're going to add the treats to it. So in other words, she's adding $1 times each treat. And we know that she can't spend any more, or she's going to spend less than or equal to $25. So I've taken what I've been talking about there and put that into inequality. 9 times 2 plus 1x is less than $25. Now, I like to simplify it and make it even a little more algebraic. I'm going to multiply 9 times 2, and I like really for my variable to come first, and I don't like to write 1 in front of the variable. So I'm going to rewrite this using the commutative property. I can change the order, commutative property of addition. I'm going to rewrite it this way. I'm going to say x plus 18 is less than or equal to 25. And my problem said just write an inequality. It didn't say solve it. So I'm done with the inequality right there. Question on that? I'll give you just a second more to jot that down. And on that same assignment I gave you on Thursday, we're actually going to skip a few. I want to move to the next word problem, problem number 8. So if you're looking at that online, go ahead and look at it. I'm going to also put it up in front of you. So let's move on to problem number 8. Remember, if you're watching this as a video, you can pause the video and come back to it any time. All right, so number 8 says this. It says to write now and solve an inequality for each problem. So we're going to start out with problem number 8, and it says that by selling old CDs, everybody here know what a CD is? That's getting to be kind of a dated term.
Compact.
Yeah, compact disc. Sarah has a store credit for $153. A new CD cost $18. What are the possible numbers of new CDs Sarah can buy? Let's write down some information. First of all, for problem number 8, I always put the problem number down. Sarah has in her possession $153. Okay, that's kind of good to know. We also know a new CD costs $18 each. So we need to establish a variable. Anybody want to throw a variable at me? Trey, you got one. Give me a variable. E, okay? We'll let E equal the number of CDs that she can buy. Now, what do we know? Can she spend $153?
Yes.
Can she spend $154?
No.
Now, so we know this has got to be less than or equal to 153. And we don't know how many she needs to buy, but we know that they cost $18 each. So 18 times the number of new CDs she buys will tell us how many that she can buy and not exceed that amount of $153. So my inequality I've written is 18 times C is less than or equal to 153. So that's when I approach an inequality, I approach it exactly the same way that I do solving an equation. I've got both sides are multiplied, or both 18E times 153. I can use the division property of equality and divide both sides by 18. So that these cancel. And I'll be left with E is less than or equal to 153 divided by 18. Now, when I divide 153 by 18, I get 8.5. So I need to write a statement out. Sarah can buy 8 or less CDs. Wait a minute. Why did I say 8 or less? Yes, sir.
Because if she buys more than 8, she will go over her budget.
Well, yeah, but it said I could buy 8.5. What?
can't buy half of this.
Ah, exactly. Very good. You know, I didn't write down that she can buy 8.5 CDs. You can't, Devin's got it right. You can't buy half a CD. If you could, it wouldn't play. Just go, because it's spun around. Good job. Good answer. All right, let's look at number 9. Hint, hint. This is a good test question. Did you hear what I said? Hint, hint. This is a good test question. All right, so Ted needs an average of at least 70 on his 3 history tests. Now, he has already scored 85 and 60 on 2 tests. What's the minimum grade Ted needs on his 3rd test? All right, so here we go, number 9. He wants to make a grade of at least 60, an average. I said 60, I really meant an average of at least 70. Which means he wants that grade to be greater than or equal to 70. Can his average be a 71? Yeah. Can his average be 100? Well, not with a grade of 85 and 60, but yeah, it'd be nice if it were. So what we want to know is, what is the minimum grade? Well, the first test, test 1, he made an 85 on. Okay? And then test 2, he made a 60 on. And what we don't know is what he needs to make on test 3. How about we use T as a variable there for test? Well, the first thing it's really important to know is, how do you average grades? You may know how you do that? What do you do? Yes, sir. Perfect. Yeah, you add the tests together. So we'll say 85 plus 60 plus the one we don't know, T. And you divide by the number of tests. So here's 1, 2, 3 tests. Okay? And we want to know, when is that average greater than or equal to 70? So I took the 3 tests, I add them up, divided by 3, and I said that needs to be greater than or equal to 70. Well, go ahead and solve that inequality. It's the first step there to solve it is to multiply both sides by 3. Because remember, that's the way that I clear my denominator. All right, so I'll have 85 plus 60 plus T is greater than or equal to 210. And I'll go ahead and add 85 and 60 together. 85 plus, do what?
145.
Yeah, 145. Plus T is greater than or equal to 210. So I know now to solve this equation, I need to use the subtraction property. I need to get rid of this 145 on both sides. I say subtract 145 here, subtract 145 here, and then T will be greater than 210 minus 145, and that answer is 65. So Ted must make at least 65 or better. His test score needs to be greater than or equal to 65. So let's look at one more word problem. This one says that Jay can buy a stereo either online or a local store. If he buys online, he gets a 15% discount, but also has to pay a $12 shipping fee. Okay, so online is 15% discount, and then there is a $12 shipping fee. At a local store, the stereo is not on sale, but there's also no shipping fee. For what regular price is it cheaper for Jay to buy the stereo online? Well, first of all, we need a variable. And we'll just say let P equal the price of the stereo. Now, if P is the price of the stereo, the cost of it online is going to be 0.15 P plus 12. Now, let me explain to you how I'm getting this, okay? It's 0.15 P, that's the discounted rate, okay? And we're actually going to subtract that from the cost. So there's something we need to figure out here just for a second. If he gets a 15% discount, then he has to pay for 85% of it. So if he pays for 85%, 85% is 0.85. Okay, so the online cost is 0.85 P plus the $12. In other words, 15% off means he pays for 85% of it. And we write 85% as 0.85, then we'll add the $12 to it. So that's the cost online. And we know in the store, it's just the cost, P. So what we're trying to find here is for what regular price is it cheaper to buy online than it is to buy in the store. Okay, so here's how I'd write that as an inequality. This is kind of key. The key to this problem is this. We want to know when 0.85P plus 12 is less than what it costs in the store. So from here on out, it's just a matter of solving the equation. We want to know when the online cost is less than the in-store price. If I wrote that in words, I'd say the online cost is less than the store price. And that's how I set up my inequality. Put the online cost here, less than the store price. So really, most of the battle there is setting up the inequality. Then we want to solve it. Yes, sir?
Would you subtract 12 from both sides?
You can. So the first step might be to subtract 12 from both sides. We can do that. So to be minus 12 like that. And those cancel, so I'll be left with 0.85 P is less than P minus 12. Okay? So if I made that step, which is fine. Oh, well, this is 0.85p. Then my next step would be to subtract 1p from both sides because I get my variables on the same side. Okay, so I'd say minus 1p here and minus 1p here as well. And we got to remember decimal subtraction. If I say that 0.85 minus 1, then I'm left with a negative 0.15 is less than negative 12, 1.5p. Then my next step is to divide both sides by negative 0.15. Now I'll do something here, okay? Because I divided by a negative on both sides, these will cancel, but I have to do something else with my inequality sign. Because I divided by a negative, the inequality sign has to reverse direction. Anytime I multiply or divide by a negative, that has to happen. That means negative 12 divided by negative 15 will be a positive answer. So 12 divided by decimal 15 or 15 hundredths would be 80. So when the price is greater than $80, it is cheaper to buy it online. So that was a pretty challenging little problem, but it's one that you can do. Right, so questions on that? All right, so that takes care of solving some inequality word problems. So moving to the assignment I gave you on Friday, here I just gave you some inequalities to solve. But there's some other things I want to be sure we know how to do. One is how to graph that answer, and then how to put that answer in interval notation. So we're going to look at 3 problems from this assignment. The first one's number 1, so write that down. The problem is this. It's 3x plus 12 minus 6x is less than or equal to negative 9. So what we're going to do is we're going to solve this just like we would if it were an equation. We're not even going to worry about the greater than or less than, in this case, less than or equal to sign. We're just going to approach it the very same way we would in solving an equation. If we multiply or divide by a negative, then we'll reverse our sign. So the first thing we'll do is I'm going to combine like terms. I've got a positive 3x and a negative 6x. If I put those together, I get negative 3x plus 12 is less than or equal to negative 9. All I did was put my like terms, positive 3x and negative 6x together. Now I subtract 12 from both sides. And I'm left with negative 3x is less than or equal to negative 21. All right, so what did I divide by? Yeah. Now, somebody said I divide by -3. Emphasis on that answer, -3. Here's what's got to happen. When I divide by negative, the sign must reverse. No longer is it less than or equal to, it becomes greater than or equal to. All right? So these two cancel, and I'm left with x is greater than or equal to
7.
+7, yes. Now, I'm not done here because these problems ask for us to solve, graph, and give my answer in interval notation, which is not hard. So the first thing I'm going to do is I'm going to graph it. When I graph them, I just make a straight line, and I'm not going to worry about a whole lot of places on the number line. It's greater than 7, so we're going to have 6, 7, 8, 9, 10, like that. And I'm going to put a closed dot on 7. Now, I'm putting a closed dot on 7 because it is greater than or equal to. If it didn't have the equal to portion of that, then I would put an open dot, one that's not filled in. And it says x is everything equal to or greater than 7. That's what it says. That's what that means. So that means my graph is going to look like that. Kind of a shortcut, kind of an easy way to remember it is that if my variable's on the left, my inequality sign points the same direction that my arrow has to on my graph, if that helps you. And then there's this business of interval notation. So in interval notation, I'm going to put a bracket down, meaning that it's equal to 7, and an infinity sign here, meaning it goes forever in the positive direction. I'll put a parentheses after infinity because it never actually equals that. The bracket means that it's equal to 7, and it goes to the right to infinity. So that's the answer in interval notation. To me, in a way, it kind of looks like my graph. If my arrow is pointing to the right, then my infinity sign will be on the right. If my arrow is pointing to the left, my infinity sign will be to the left, but it'll also be negative infinity instead of positive infinity, indicating we're going to the left. And we'll look at some problems like that as well. That's the solution. I've solved it, I've graphed it, and I've written my answer in interval notation. For number 2, we are going to solve, graph, and write our answer in interval notation. The problem is x plus 5x minus 6 is less than 12. Step 1, what's the first thing we do? Yeah, combine like terms. X and 5x, 6x minus 6 is less than 12. Next step. Add 6 to both sides. Perfect. Just like we would in an equation. So now I'm left with 6x is less than 18. At this point, another divide by 6. And x is less than 3. Why didn't I reverse the sign? Yeah, I divided by positive. Only when I multiply or divide by negative. Doesn't matter if I add or subtract. It's only when I multiply or divide by a negative. So I divided by a positive here. So I don't reverse that side. Keep my graph simple. It's less than 3. So I'm going to say 4, 3, 2, 1, 0. And then since it's less than 3, I'm going to put a dot on 3. I know that this number tells me where I'm going to put that circle. In this case, the circle I'm going to put there is open.
A through R. Can you go to the auditorium and get their picture taken? Thank you.
It's open because it's less than without an equal to. So that means it doesn't include 3, but it's every value less than 3. So x is less than 3. In interval notation, I'll use a parentheses instead of a bracket because it's not equal to 3. And it's every number less than, so I'll use a negative infinity sign, meaning anything from 3 less than. That's the answer that is solved, graphed, and written in interval notation. Remember, the bracket will mean that it's equal to the number it's around. A parentheses will mean it's not equal to that number. The infinity tells me whether it's numbers larger or negative infinity, numbers smaller. Remember, we need to solve, graph, and write our answer in interval notation. Then we'll skip number 3 and go to number 4 in the handout. So this problem is 5x minus 7 times x plus 1 is greater than negative 9. So to solve it, what's my first step? So we want to use the distributive property to multiply negative 7 times x, and we'll get negative 7x. And negative 7 times negative 1 will get negative 7, and that's greater than negative 9. Next step, I would combine like terms, right? 5x minus 7x is negative 2x. Minus 7 is greater than negative 9. Now I need to add 7 to both sides. I'll be left with negative 2x is greater than negative 9 plus 7, which is negative 2. What's my next step?
Divide by 2.
Divide by what kind of 2?
Negative.
Ooh, divide by negative 2. What does that mean? What I have to do?
Cancels both of them.
It does cancel. It also means something else for my inequality. What does it mean? Yeah, I have to reverse the sign, and negative 2 divided by negative 2 is positive 1. So my solution is x is less than positive 1. You got to be real careful. Anytime you multiply or divide by the negative, you'll reverse the sign. If you don't reverse the sign, it don't matter that every step you've made has been correct. It'll be counted wrong. Which brings us to the number line. Okay? So it says x is less than 1, so I'll just include a few numbers on my number line. It is less than 1, so I put an open circle. on 1. And every value less than positive 1 is a solution. Okay, so my arrow is going to go to the left. I want to write that answer in interval notation, so I'm going to include 1 with parentheses because it's not equal to it. And it goes to the left, so that's negative infinity, where all my negative numbers are. So an interval notation is negative infinity and 1. Remember, my infinity sign is going to go on the side in the interval notation where my arrow is pointing. So we've been able to solve, graph, and write our solution in interval notation of this inequality.